Hi everyone, welcome to Chem class. I've just been out at a afternoon tea that was being hosted by a chemistry friend, and they invited a whole bunch of chemistry teachers, and so we had a lot in common, and I did hang around longer than I had expected to. Must admit, while I was there though, a geography teacher turned up and they lasted a sip of water and half a Scotch finger biscuit before they were definitely on their way, not interested in hanging out with us too much. That's okay. What I'm trying to explain to you today is chromatography. And in any chromatography setup, there is a stationary phase and a mobile phase. The house that the afternoon tea was at, hosted by the chemistry teacher, was the stationary phase. So because there was something in common, such as the polarity of myself and the person hosting, I definitely spent a lot of time there. So in chromatography, when the molecules have something in common with the stationary phase, they spend a lot more time adsorbed to the stationary phase. When a molecule has a different polarity, so for example, if the stationary phase is polar and something comes through that is non-polar, the geography teacher, then they'll tend to pass through the stationary phase quite quickly because there's not a lot of attraction holding them in that particular space. So we can look at the time or the distance that a particular particle has travelled to determine what their polarity is, or even their size, because we know that there is a link between polarity and size of molecules. Let's have a look at all these terms on paper. Okay, so let's look at a very simple chromatography setup. So this resembles paper chromatography, but thin layer chromatography is very similar. It's all the same principles. And as I mentioned earlier, every chromatography setup will have a stationary phase and a mobile phase. Just to be clear, the stationary phase means it's stationary. It's the part of the setup that stays still. So things pass over it or through it. And the mobile phase is the thing that moves. So it could be water or a water methanol mix or a gas or something, but it's something that moves through the chromatography setup. So something's always still and something's always moving through. And the mobile phase is carrying the sample. So in this case, the sample was placed at the origin. You might have modelled something like this in class with some ink or Smarties colouring, for example. And the components will separate out. So that's the whole point. We're trying to separate out the components, knowing that every component inside a mixture is going to have some kind of uniqueness or difference, and polarity is a very good characteristic to be separating particles out by. So in this case, I've got a purple and a green dot. Very simple. The stationary phase is paper, and what we can see is from the point of origin, the green has travelled further than the purple. So what does that mean about the attraction between those two colours with the paper, with the stationary phase? If something takes longer to travel through the chromatography setup, it means that it is more attracted to the stationary phase. And the word that we use is adsorb or adsorbed. Adsorb means to stick to. So the purple has adsorbed to the stationary phase more strongly than the green. Or we could say that the green has adsorbed less strongly to the stationary phase than the purple. Conversely, we can also talk about the two particular components and how much they want to dissolve into the mobile phase. If something has moved further or faster, it means that it is more readily dissolving in the mobile phase, and that's why it's being carried through a lot faster. Now, as I mentioned earlier in my introduction, if we're talking about polarity and our stationary phase has a particular polarity and something sticks longer to it, it tells us something about the polarity of that particle. If the mobile phase, the solvent in this case, is water, and we know that water is polar, so let's write that down. If we're using water in our paper chromatography, let's say that water is polar. What that means is, out of these two particles, we can now tell something about the polarity of each of them, which one is more polar than the other. If the green has moved faster, as I said, it has dissolved more readily in the mobile phase. And being that the mobile phase is polar, like dissolves like, it means that the green must be more polar than the purple. We don't tend to go to polar versus non-polar for these particles. We talk about more polar versus less polar. Because if, for example, your two particles both have some kind of polarity, but one happens to be bigger, it means the effect of the polarity on the smaller molecule is more significant, and that's why it will dissolve more readily in your mobile phase. Hope that helps.